Hidden in the depths of the Perseus Cluster lies a cosmic oddity that defies everything we thought we knew about galaxies. Meet NGC 1277, a relic from the early universe that has astronomers scratching their heads. This isn't your average galaxy. Unlike most of its neighbors, this lenticular giant stopped forming stars billions of years ago, frozen in time like a fossil from the dawn of creation. But what makes it truly bizarre, it's packed with an overwhelming amount of dark matter, yet somehow seems to lack the dark matter halo that should surround it. And that's just the beginning. This ancient cosmic enigma holds at least 50 strange phenomena that challenge our understanding of the universe. From a supermassive black hole that shouldn't exist to stars with impossible chemistry, NGC 1277 is rewriting the rules of galactic evolution. Stay with us as we unravel these mysteries one by one, revealing why this galaxy is unlike anything else in the known cosmos. By the end of this journey, you'll see why scientists call it the most puzzling relic of the early universe, and why its secrets could change astronomy forever. Now let's zoom in on the first mind-bending puzzle of NGC 1277, something that has left scientists utterly baffled. This galaxy seems to be missing something crucial: its dark matter halo. Picture this: every galaxy we've studied, from massive spirals to tiny dwarfs, is wrapped in a vast, invisible cloak of dark matter. It's what holds them together, shaping their structure and guiding their evolution. But when astronomers peered into NGC 1277, they found something shocking. The numbers just didn't add up. The stars and gas in this galaxy move in ways that suggest there's hardly any dark matter at all surrounding it. That's like finding a skyscraper standing tall without a foundation. It shouldn't be possible. So what's going on here? One theory suggests that NGC 1277 might have been stripped of its dark matter long ago, perhaps by a violent encounter with another galaxy. Imagine two giants colliding in space, with one galaxy's gravity ripping away the other's invisible shield. Another idea is even more radical. What if this relic galaxy never had much dark matter to begin with? That would turn our entire understanding of galaxy formation upside down, because dark matter is supposed to be the scaffolding that pulls ordinary matter together to build galaxies in the first place. Without it, how did NGC 1277 even form? Right now, astronomers are racing to solve this mystery. Some are searching for traces of dark matter that might be hiding in unexpected places within the galaxy. Others are running supercomputer simulations to recreate its strange history. Whatever the answer turns out to be, one thing is clear: NGC 1277 is forcing us to rethink one of the most fundamental rules of the cosmos, that dark matter and galaxies go hand in hand. And if this galaxy can break that rule, what other cosmic surprises are waiting out there? But here's another twist that makes NGC 1277 even more baffling. At the heart of this galaxy lurks something so massive, it defies everything we thought we knew about cosmic balance. The supermassive black hole here isn't just big, it's a monster, weighing in at a staggering 17 billion times the mass of our Sun. To put that in perspective, most galaxies have black holes that make up a tiny fraction of their total mass, like a pebble in a vast ocean. But in NGC 1277, the black hole dominates, accounting for nearly 15% of the galaxy's entire mass. That's like finding a bowling ball sitting in the middle of a small kiddie pool. It just doesn't add up. So why does this break the rules? Normally, black holes and their host galaxies grow together, with the black hole making up just a fraction of a percent of the galaxy's mass. But this one is so oversized, it's as if the galaxy stopped growing while the black hole kept feasting. One theory suggests that NGC 1277 might have been part of a cosmic collision long ago, funneling vast amounts of gas and stars straight into the black hole's grasp, supercharging its growth. Another idea is that this galaxy is a rare relic preserving conditions from the early universe when black holes could grow unchecked. What's even stranger is how quiet this black hole is. Despite its mind-bending size, it's not spewing jets of energy or glowing brightly like other supermassive black holes. It's almost as if it's hiding, lurking in the shadows of the galaxy. Astronomers are piecing together clues, studying how such a colossal black hole could exist without leaving more obvious traces of its power. Every new observation challenges our understanding of how black holes shape galaxies, and how galaxies in turn control their black holes. NGC 1277 isn't just an oddity. It's a cosmic rebel forcing us to rewrite the rulebook on how the universe works. And if this black hole can break the rules, what else might be out there waiting to surprise us? Now here's something else that doesn't quite fit the cosmic puzzle of NGC 1277. Its stars are packing way more metal than they should be. Normally, older galaxies like this one, which have been around since the early universe, are expected to have stars with lower metal content. Metals, in cosmic terms, are elements heavier than hydrogen and helium, things like iron, oxygen, and carbon. These elements are forged in the cores of stars and scattered into space when those stars explode. Over time, newer generations of stars form from these enriched materials, becoming more metal-rich. But in NGC 1277, something unusual happened. Its stars are loaded with metals, way more than you'd expect for a galaxy that stopped forming new stars billions of years ago. This throws a wrench into our understanding of galactic evolution. Normally, high metallicity suggests a history of rapid, intense star formation, like a cosmic boom where stars were born in huge numbers, lived fast, died young, and enriched their surroundings with metals. But here's the catch: NGC 1277 doesn't show signs of recent star formation at all. So how did its stars end up so metal-rich? One possibility is that this galaxy had an incredibly violent and productive youth, churning out stars at a breakneck pace before abruptly shutting down. Imagine a factory working at full capacity, then suddenly going silent, leaving behind only the high-quality products it made in its prime. Another theory is that NGC 1277 might have cannibalized smaller, metal-rich galaxies in its past, absorbing their stars and their heavy elements without triggering new star birth. Or perhaps the galaxy's supermassive black hole played a role, stirring up gas clouds in a way that concentrated metals into the remaining stars. Whatever the explanation, this high metallicity is another clue that NGC 1277 doesn't follow the usual rules. It's like finding an ancient artifact made with modern precision. It forces us to rethink how galaxies live, evolve, and leave their mark on the universe. And with every oddity we uncover, the story of this galaxy grows even more intriguing. But here's where NGC 1277 really stands out. It's missing something most galaxies have in abundance: young stars. Picture a bustling city where no new buildings have gone up in billions of years. That's essentially what this galaxy looks like. While most galaxies, even older ones, still have pockets of young, blue stars being born from leftover gas and dust, NGC 1277 is eerily quiet on that front. Its stars are almost all ancient, glowing red instead of blue, with no signs of fresh stellar nurseries. This makes it what astronomers call a relic galaxy, a cosmic time capsule preserving conditions from the early universe. Typically, galaxies either keep forming new stars at a slow pace or experience bursts of star birth when they collide with others. But NGC 1277 seems to have shut down star production entirely, and nobody's entirely sure why. One leading idea is that it ran out of fuel long ago. Star formation requires cold gas, and if something like its supermassive black hole or interactions with neighboring galaxies siphoned or heated up all that gas, the factory simply closed its doors. Another possibility is that this galaxy never had much gas to begin with, forming most of its stars in one rapid, intense burst before going dormant. Either way, the absence of young stars is another piece of the puzzle that sets this galaxy apart. It's like stumbling upon a ghost town where everything froze in time, leaving behind only the echoes of an ancient, frantic construction phase. And that raises even bigger questions. How many other relic galaxies are out there? And what can they teach us about the universe's early days? The silence of NGC 1277 might just hold the answers. Now, let's turn our attention to another baffling feature of NGC 1277, its eerie radio silence. When a galaxy hosts a supermassive black hole as colossal as the one at its core, astronomers expect to detect strong radio emissions. These emissions usually come from jets of high-energy particles blasted outward as the black hole devours surrounding matter. But here's the twist: NGC 1277 is nearly mute in radio waves, defying expectations. This absence is especially puzzling because black holes of this size are almost always active, spewing out radio noise as they feed. So why is this one so quiet? One theory suggests the black hole might be in a dormant phase, having already consumed most of the nearby gas and dust, leaving it with little to no material to emit. Another idea is that the black hole's jets, if they exist at all, might be pointed directly away from our line of sight, making them invisible to our telescopes. But there's a deeper mystery here. Even dormant black holes usually leave traces of past activity in their surroundings: heated gas, shock waves, or residual radiation. Yet NGC 1277 shows none of these typical signatures. It's as if its black hole has always been silent, which challenges our understanding of how these cosmic giants behave. Could this galaxy's unique environment have suppressed radio emissions altogether? Or is there some unknown mechanism at work shutting off the black hole's voice? Whatever the reason, this radio silence adds another layer to the enigma of NGC 1277. It's not just a relic of the past, it's a galaxy that refuses to follow the rules, forcing us to rethink what we know about black holes and their cosmic footprint. And with each unanswered question, the intrigue around this ancient galactic oddity only grows. Now, let's shift our focus to something even more perplexing: the gravitational anomalies lurking at the heart of NGC 1277. When astronomers study galaxies, they expect the gravitational pull at their cores to match the amount of visible matter, like stars and gas. But here, the math just doesn't add up. The forces at play are far stronger than what we can account for with the galaxy's visible components alone. This discrepancy suggests something invisible is tugging at the fabric of space around the core. Dark matter is the usual suspect in cases like this, but remember, NGC 1277 already defies expectations by appearing to lack a traditional dark matter halo. So what's causing these bizarre gravitational effects? One possibility is that the galaxy's supermassive black hole, already unusually massive, is warping spacetime in ways we don't fully understand. Another theory points to hidden pockets of dark matter clustered near the core, behaving differently than in typical galaxies. What makes these anomalies even stranger is their scale. The gravitational weirdness isn't just a slight deviation. It's a glaring mismatch that challenges our fundamental models of how galaxies work. If visible matter can't explain it, and dark matter isn't where we expect it to be, what invisible hand is shaping this galaxy's core? Some researchers speculate that NGC 1277 might harbor exotic forms of matter or even unknown physics at play. Others wonder if past collisions or mergers left behind gravitational scars we're only now detecting. Whatever the answer, these anomalies remind us that the universe still holds mysteries no textbook has cracked yet. And as we peel back the layers of NGC 1277's secrets, each discovery only deepens the puzzle. Shifting gears from the gravitational puzzles at the core, let's zoom out to another head-scratcher: the strange story of NGC 1277's globular clusters. These dense, ancient collections of stars usually orbit galaxies like bees around a hive, but here they're breaking all the rules. Most galaxies this size have a few hundred globular clusters at most, but NGC 1277 boasts an astonishingly high number packed into an oddly lopsided arrangement. What's really eyebrow-raising is how these clusters are distributed. Instead of evenly surrounding the galaxy, they're clumped together in ways that suggest a turbulent history. Picture this: if globular clusters were breadcrumbs, they'd trace a path of chaos, hinting at epic collisions or mergers that reshaped the galaxy long ago. Some clusters even appear to be moving in sync, as if they were once part of a smaller galaxy devoured by NGC 1277. The age of these clusters adds another layer of intrigue. Many are far older than the galaxy's stars, suggesting they weren't born here but were captured during violent encounters. It's like finding antique furniture in a modern house. It tells a story of how the place was built. One leading theory is that NGC 1277's insatiable appetite for smaller galaxies left this messy aftermath. Another idea: the galaxy's extreme environment, perhaps shaped by its monstrous black hole, prevented these clusters from dispersing normally. Either way, their presence challenges our ideas about how galaxies grow and interact. As we piece together the clues from these ancient stellar swarms, one thing's clear: NGC 1277 didn't form quietly. Its globular clusters are cosmic fingerprints, pointing to a past filled with collisions, cannibalism, and forces we're only beginning to understand. And just like the rest of this galaxy, they refuse to fit neatly into any textbook model. Now, let's turn our attention to another baffling signature of NGC 1277, the mysterious X-ray flares that have left astronomers scratching their heads. Unlike typical galaxies with supermassive black holes, which often emit steady streams of X-rays as they devour nearby matter, this galaxy's X-ray activity is erratic and unpredictable. Picture a flashlight flickering at random intervals with no clear pattern or explanation. What's especially puzzling is that these bursts don't match the behavior of its colossal black hole. Normally, a black hole of this size should produce constant, high-energy X-rays as it pulls in gas and stars. But in NGC 1277, the X-rays come in sudden, short-lived spikes, then vanish for long stretches. It's as if something else, something unseen, is either triggering these emissions or masking the black hole's expected activity. One possibility: hidden cosmic phenomena like dense clouds of matter collapsing or exotic objects interacting in ways we don't yet understand. Another theory suggests the black hole itself might be hiccuping, with its feeding process disrupted by unknown forces. Or perhaps the galaxy's strange dark matter properties are playing a role, warping space in ways that occasionally release bursts of energy. Whatever the cause, these X-ray mysteries add another piece to NGC 1277's enigma. They challenge our assumptions about how black holes behave and remind us that even the most advanced telescopes can't always decipher a galaxy's secrets at first glance. And as we'll see next, this isn't the only paradox this cosmic relic has in store. Now, shifting our gaze to yet another contradiction, let's unravel the mystery of NGC 1277's so-called red and dead status, a label that doesn't quite tell the whole story. Most galaxies tagged as red and dead are cosmic retirees, their star-forming days long behind them, leaving behind only aging, reddish stars. But this galaxy defies expectations by flaunting traits that scream youth and activity, like a grandparent suddenly taking up extreme sports. For starters, its stars are unusually metal-rich, a hallmark of vibrant, younger galaxies where supernovae have peppered the cosmos with heavy elements. Yet, NGC 1277's star formation flatlined billions of years ago. How, then, did it amass such a metallic stash? One theory suggests it gulped down smaller, gas-rich galaxies in its youth, absorbing their metals in a frenzy before going dormant. Another idea points to its ancient stars forming in a uniquely metal-enriched environment early in the universe, a cosmic gold rush we've yet to fully understand. Even stranger, the galaxy's structure mirrors that of lively spirals with a well-defined disk and bulge, unlike the messy, bloated shapes typical of aging ellipticals. It's as if NGC 1277 froze in time during its prime, preserving a snapshot of its glory days while the universe moved on. This paradox forces astronomers to rethink what red and dead really means. Could some galaxies shut down star formation while retaining their youthful vigor through other means? Or is NGC 1277 a rare hybrid, a relic that straddles two cosmic eras? As we peel back these layers, the line between ancient and active grows fuzzier, and the galaxy's secrets only deepen. Next, we'll dive into the ghostly whispers of dark matter that might hold even more clues. Turning our attention to what lies beneath the surface, the mystery of dark matter in NGC 1277 takes another twist. While earlier observations suggested this galaxy might lack the typical dark matter halo, newer research paints a more complicated picture. Scientists now suspect the missing dark matter isn't actually missing at all. It might just be hiding in plain sight, woven into the galaxy's structure in ways we're only beginning to detect. Groundbreaking studies propose that dark matter here could be locked into an unconventional arrangement, perhaps clumped into dense knots or stretched into filaments that evade traditional detection methods. Unlike the smooth, diffuse halos seen in most galaxies, NGC 1277's dark matter might be concentrated along its disk or even intertwined with its stars, subtly influencing their motion without the usual gravitational footprint. Some theories go further, suggesting exotic forms of dark matter particles that interact differently with normal matter or even with themselves could explain the anomalies. If true, this galaxy might be a testing ground for physics beyond our current understanding. What makes this puzzle so compelling is how it challenges two assumptions at once, not just how galaxies hold together, but what dark matter itself is capable of. Could NGC 1277 be a cosmic outlier, or a sign that we've been overlooking hidden dimensions of dark matter all along? As telescopes peer deeper, the answers might redefine not just this galaxy, but the rules of the cosmos. Next, we'll explore why this enigmatic galaxy seems to orbit in solitude, devoid of the usual entourage of smaller satellite galaxies. Now, shifting our gaze to the cosmic neighborhood of NGC 1277, another baffling mystery comes into focus: the curious absence of satellite galaxies. Most large galaxies, including our own Milky Way, are surrounded by a swarm of smaller dwarf galaxies, cosmic companions held in orbit by gravity. These satellite galaxies are like puzzle pieces, remnants from the early universe that help us understand how galaxies form and evolve. But NGC 1277 defies expectations. It stands almost entirely alone, without the usual entourage of these smaller galaxies, and astronomers are scrambling to figure out why. This absence is more than just a cosmic oddity. It challenges the very foundations of our cosmological models. According to simulations, a galaxy as massive as NGC 1277 should have at least a handful of satellite galaxies trailing behind it, just as we see with other galaxies of similar size. Their absence suggests something unusual happened in this galaxy's past. Did some violent event strip them away, or did they never form in the first place? One possibility is that NGC 1277's turbulent history played a role. If it formed in a particularly dense region of the early universe, interactions with neighboring galaxies might have torn away its satellites over billions of years. Another theory points to the galaxy's massive central black hole, whose gravitational influence could have disrupted or even destroyed potential satellite galaxies before they had a chance to settle into orbit. But perhaps the most intriguing explanation ties back to dark matter. If NGC 1277's dark matter is distributed in an unconventional way, unlike the smooth halos seen in other galaxies, it might have failed to gather the necessary material to form satellite galaxies in the first place. This would mean the galaxy's dark matter structure not only affects its internal dynamics but also its cosmic surroundings. Whatever the cause, the missing satellites add another layer to the enigma of NGC 1277. It's a reminder that even the emptiest spaces in the cosmos can hold the most profound questions. Next, we'll turn our attention to the stars racing around this galaxy's core at speeds that shouldn't be possible, a phenomenon that further blurs the line between what we know and what still eludes us. Now, let's zoom in on the stars themselves, because something strange is happening in the heart of NGC 1277. These stars aren't just drifting lazily around the galactic center. They're racing, moving at speeds that defy logic based on the visible mass of the galaxy. Imagine swinging a ball on a string, only to realize the ball is moving so fast it should have flown away by now unless there's an invisible hand holding it in place. That's the puzzle astronomers face here. Normally, the speed of stars orbiting a galaxy's core depends on the gravitational pull of all the matter inside their orbit stars, gas, and especially dark matter. The faster they move, the more mass there should be holding them in place. But in NGC 1277, the stars are zipping around so quickly that the visible matter alone can't explain their velocities. This discrepancy points to something unseen yanking on them with immense gravity. So what's behind this cosmic speed trap? One leading suspicion is dark matter. If NGC 1277's dark matter is packed unusually close to the center, unlike the more spread out halos seen in other galaxies, it could create the extra gravitational grip needed to keep these stars from flying off into the void. But here's the catch: if that's true, it contradicts our current understanding of how dark matter should behave. Most models predict it forms a diffuse halo, not a concentrated knot. Another possibility is that the galaxy's supermassive black hole, already defying expectations with its sheer size, is warping space-time more intensely than predicted, effectively giving nearby stars a gravitational slingshot. Or perhaps there's a hidden population of dead stars, black holes, or other dense objects adding unseen mass. Whatever the cause, these high-speed orbits are a glaring clue that NGC 1277's secrets run deeper than we've imagined. This isn't just about fast-moving stars. It's a challenge to our very understanding of gravity and mass in galaxies. Up next, we'll examine another piece of the puzzle: the lopsided swirls of dust that hint at a turbulent past for this cosmic oddity. Now, let's shift our gaze to something equally puzzling: the chaotic swirls of dust drifting through NGC 1277. Unlike the neat, symmetrical dust lanes we often see in galaxies, this one's dust is strewn about in lopsided, uneven patterns, almost as if someone stirred it violently and left it unsettled. These jagged dust lanes aren't just cosmetic quirks, they're cosmic breadcrumbs pointing to a turbulent past. So why does dust matter? In galaxies, dust isn't just space dirt, it's a storyteller. It's forged in the hearts of dying stars, then scattered by stellar winds or explosions. Normally, dust settles into orderly rings or spirals shaped by a galaxy's rotation. But in NGC 1277, the dust is clumped and uneven, with some regions oddly dense while others are eerily bare. This asymmetry screams disruption, hinting at a history far from peaceful. One possibility: a past galactic collision. When galaxies merge, their gravitational tugs can fling dust into chaotic arrangements, much like tossing a handful of sand into a whirlpool. Yet, strangely, NGC 1277 shows no obvious signs of a recent merger, no stretched-out tidal tails or warped companion galaxies. That leaves astronomers scratching their heads. Could the dust have been thrown off balance by an internal upheaval, like a burst of ancient star formation stirring things up? Another clue lies in the dust's unusual composition. Some patches appear richer in certain minerals, suggesting they weren't all produced the same way or at the same time. It's as if the galaxy's dust has multiple origins, some from quiet stellar aging, others from violent stellar deaths, all jumbled together. This mishmash only deepens the mystery. How did a galaxy with so little recent star formation end up with such a messy dust reservoir? Whatever the cause, this uneven dust distribution is more than a galactic oddity. It's a puzzle piece in NGC 1277's larger enigma. Up next, we'll explore why this galaxy seems frozen in time, a relic untouched by the usual forces of cosmic evolution. But here's where things get even stranger. While most galaxies evolve, adapt, and change over billions of years, NGC 1277 seems to have hit the cosmic pause button. Picture a time capsule sealed away in the early universe, except this one is an entire galaxy, preserving conditions we'd expect to see billions of years ago. Astronomers call this the frozen evolution theory, and if it's true, this galaxy could be one of the rarest relics in the cosmos. So what does it mean for a galaxy to be frozen in time? Normally, galaxies grow by merging with others, forming new stars and recycling gas and dust. But NGC 1277 appears stuck in its ancient state, with almost no new stars being born and little sign of interactions with neighboring galaxies. Its stars are old, its structure is unchanged, and its chemical makeup matches what we'd expect from the universe's early days. It's like finding a living dinosaur, except this dinosaur is a galaxy. How did this happen? One idea is that NGC 1277 formed in a unique environment, perhaps a sparse region where it avoided the collisions that drive galactic evolution. Another possibility is that its monstrous black hole somehow put the brakes on star formation, starving the galaxy of the gas needed to create new stars. Or maybe it exhausted its fuel supply so quickly in its youth that it simply ran out of time to change. The frozen evolution theory could rewrite how we understand galaxy lifespans. Most galaxies we see are works in progress, but NGC 1277 might be a snapshot of the distant past. And if that's true, studying it could reveal secrets about how galaxies looked when the universe was young. Next up, we'll tackle another head-scratcher: why this galaxy seems to be missing a key ingredient for star formation, leaving it quiet and dark. Now let's shift our focus to something invisible yet vital: the strange absence of neutral hydrogen gas in NGC 1277. This gas is the cosmic raw material for star formation, the fuel that keeps galaxies alive and evolving. But in this galaxy, it's nearly non-existent, leaving astronomers scratching their heads. Neutral hydrogen is like the flour in a baker's kitchen. Without it, you can't make new stars. Most galaxies, even quiet ones, hold onto reservoirs of this gas, either as a leftover from their early days or by stealing it from neighbors. But NGC 1277 breaks the mold. Observations reveal a shocking deficit, as if someone drained the galaxy's fuel tank and left it running on empty. So why does this matter? Without neutral hydrogen, NGC 1277 can't form new stars, which aligns with its frozen, ancient appearance. But the mystery is how it lost this gas in the first place. One theory points to its supermassive black hole, which might have blasted away the hydrogen with violent outbursts in the distant past. Another idea suggests the galaxy was born in a region where neutral hydrogen was scarce to begin with, like a tree sprouting in barren soil. But here's the twist: some relic galaxies do show traces of neutral hydrogen, making NGC 1277 an even bigger outlier. Its extreme lack of gas challenges our understanding of how galaxies preserve or lose their star-making potential over cosmic time. This isn't just a missing ingredient, it's a clue that could reshape how we think about galactic aging. Next, we'll explore how this galaxy's strange stellar disk defies expectations, adding another layer to its cosmic enigma. Moving deeper into the mysteries of NGC 1277, let's untangle the puzzle of its unexpectedly massive stellar disk. Picture a galaxy's disk like the layers of a cosmic pancake. Most follow a predictable recipe with a balanced mix of stars and gas. But this galaxy's disk breaks all the rules, packing far more stellar mass than models predict, as if someone added an extra scoop of batter to the mix. What makes this so baffling? In most galaxies, the disk's mass aligns neatly with the bulge, the dense central region. But here, the disk outweighs expectations by a staggering margin, defying theories about how such structures form. One leading explanation suggests that NGC 1277 gobbled up smaller galaxies long ago, funneling their stars into the disk without triggering the usual chaos of mergers. Imagine quietly absorbing your neighbor's furniture into your home, only for your living room to end up inexplicably heavier. Yet there's a catch. If mergers were the culprit, we'd expect visible scars, tidal streams, or distorted orbits. But NGC 1277's disk is eerily pristine, leaving astronomers to wonder if it formed this way from the start. Some propose that extreme conditions in the early universe, like denser gas clouds or faster star formation, could have birthed this heavyweight disk outright. This overmassive disk isn't just a cosmic oddity, it's a wrench in the gears of our current galactic models. If disks can form this way, it forces us to rewrite the playbook on how galaxies assemble and evolve. Next, we'll turn our attention to the galaxy's silent giant, the supermassive black hole that defies expectations by staying strangely quiet. Now, let's shift our gaze to the galaxy's enigmatic heart, the supermassive black hole that refuses to follow the script. At 17 billion times the mass of our Sun, this cosmic titan should be a raging inferno, powering brilliant quasars or spewing jets of energy across space. Yet, NGC 1277's black hole is eerily quiet, like a sleeping giant in the dark. This silence is a cosmic contradiction. Black holes of this size typically light up their surroundings as active galactic nuclei, devouring gas and dust in a dazzling display. But here, the feeding frenzy seems to have stalled. One theory suggests the black hole has run out of fuel, stripped clean by violent events in the past, leaving it starved and dormant. Picture a bonfire that's burnt through all its wood, reduced to embers. Another possibility, the black hole might be dining in secret. Some astronomers propose that it's swallowing material so slowly or inefficiently that it doesn't produce the usual fireworks. Imagine trying to light a wet log. It smolders but never truly catches fire. Or perhaps the galaxy's lack of cold gas, which we discussed earlier, leaves the black hole with nothing substantial to consume. But the plot thickens. Recent observations hint that the black hole's inactivity might be temporary, a lull between cosmic meals. If so, it could awaken in the future, transforming NGC 1277 into a blazing beacon. For now, though, its silence forces us to rethink how supermassive black holes evolve. Why do some feast while others fast? The answer could rewrite our understanding of these dark giants. Next, we'll explore how the galaxy's neighbor, NGC 1275, might be pulling the strings behind these mysteries. Now, let's unravel how a cosmic neighbor might be shaping NGC 1277's strange behavior. Just 2.5 million light-years away sits NGC 1275, a bustling galaxy with a supermassive black hole that's anything but quiet. Unlike its dormant counterpart in NGC 1277, this galaxy's black hole is a cosmic powerhouse, blasting out jets of energy and gobbling up material at a furious pace. Could this energetic neighbor be the puppeteer behind NGC 1277's oddities? Astronomers suspect so. The gravitational tug-of-war between these two galaxies might explain why NGC 1277 lost so much of its gas, the lifeblood for star formation and black hole activity. Picture a bully stealing lunch money. NGC 1275 could have siphoned off gas and dust from its quieter companion, leaving it starved and stranded. But the influence might run deeper. The intense radiation and particle jets from NGC 1275 could have sterilized NGC 1277's remaining gas, preventing it from cooling and forming new stars. Imagine trying to grow a garden in the shadow of a volcano. The environment becomes too hostile for life to thrive. There's another twist. Some scientists propose that the two galaxies might have once been a trio, with a third galaxy now merged into NGC 1275. That violent merger could have flung NGC 1277 into its peculiar state, like a survivor of a shipwreck drifting alone, yet mysteries remain. If NGC 1275 is the culprit, why hasn't it fully disrupted NGC 1277's structure? And why does NGC 1277 still cling to its ancient stars and odd dynamics? These questions hint at a far more complex relationship than we currently understand. Next, we'll dig into another layer of this galactic puzzle, the possibility of a hidden bar structure lurking within NGC 1277. Could this invisible architect be shaping the galaxy from within? Let's turn our attention to something unseen, yet potentially shaping NGC 1277 in ways we're only beginning to grasp. Hidden within this enigmatic galaxy, astronomers suspect the presence of an invisible bar structure, a cosmic skeleton that could be pulling the strings behind some of its strangest behaviors. Most barred galaxies flaunt their structure proudly, with bright, star-filled bars stretching across their cores, but NGC 1277 might be different. Here, the bar could be cloaked, detectable only by its gravitational fingerprints. Think of it like a ghostly hand stirring a cosmic pot. You can't see it, but you notice the ripples it leaves behind. What's the evidence? For starters, the galaxy's stars and gas don't move the way they should if the galaxy were perfectly smooth. Some stars race along peculiar orbits, while gas clouds seem funneled into unusual patterns. These quirks align with what you'd expect if a hidden bar were shepherding material inward, feeding the dormant black hole or stirring up the galaxy's ancient stellar population. But why would this bar stay hidden? One theory suggests the bar could be old, so ancient that its stars have faded into the background, blending seamlessly with the rest of the galaxy. Another idea is that the bar isn't made of stars at all, but of something darker. Could unseen dark matter be woven into this structure, shaping the galaxy from the shadows? Not everyone's convinced, though. Some researchers argue that the galaxy's odd motions might stem from past collisions or the influence of neighboring galaxies, like NGC 1275. Without direct visual proof, the debate remains open. Yet, if a bar does lurk within NGC 1277, it would rewrite our understanding of how relic galaxies evolve, and why this one seems frozen in time. Up next, we'll tackle another puzzle, the baffling chemistry of NGC 1277 stars, where age and metal content collide in a way that defies expectations. Now, let's unravel another cosmic contradiction hidden within NGC 12771 that pits its ancient stars against their surprisingly rich metal content. At first glance, these two traits shouldn't coexist. Older stars forged in the early universe are typically metal-poor, born before later generations could seed the cosmos with heavier elements. Yet here, the galaxy's stars flaunt a metallicity that rivals younger stellar populations, defying the usual rules of galactic aging. So how does this paradox hold up? Picture a galaxy that lived fast and died young. NGC 1277 might have formed stars at a breakneck pace early on, sucking up available gas and converting it into stars so quickly that it amassed metals far sooner than other galaxies of its era. This frenzy would have left behind a population of stars that are both ancient and metal-rich, like finding a medieval castle stocked with modern steel. Another twist, the galaxy's supermassive black hole could have played a role. In its youth, the black hole's violent outbursts might have heated surrounding gas, halting further star formation but preserving the existing stellar chemistry. That would leave NGC 1277 frozen in time, its stars untouched by later cosmic events that typically dilute metallicity in aging galaxies. But there's a puzzle within the puzzle. Some studies suggest the metals aren't evenly spread. Certain regions boast higher concentrations, hinting at past mergers or intense bursts of star formation that showered pockets of the galaxy with heavy elements. It's as if the galaxy hosted a series of cosmic gold rushes, each leaving behind a richer legacy than the last. This stellar enigma doesn't just challenge our understanding of NGC 1277, it forces us to rethink how relic galaxies evolve. Could others like it be hiding similar contradictions? Up next, we'll dig into another anomaly, the curious absence of tidal debris, which raises fresh questions about the galaxy's turbulent past. But here's something that doesn't add up: NGC 1277's pristine appearance, with no visible scars from cosmic collisions. Most galaxies with its violent history are littered with tidal debris, the shredded remains of smaller galaxies they've devoured. Think of it like crumbs left behind after a meal. Yet, this galaxy shows none of the usual stellar wreckage. So where's the mess? One explanation could be time. If NGC 1277's major mergers happened billions of years ago, the debris might have fully settled or been absorbed, leaving no trace. Imagine tossing a stone into a pond. The ripples fade and the surface goes smooth again. But that's rare. Even ancient mergers usually leave faint trails like ghostly fingerprints. Another possibility: the galaxy's supermassive black hole might have played cleanup crew. In its younger, more active days, its gravitational pull could have scattered or swallowed the debris, erasing the evidence. Or perhaps the mergers were unusually clean, with smaller galaxies falling in straight lines, minimizing disruption. Then there's the dark matter factor. If NGC 1277's dark matter behaves differently, say more spread out or in clumps, it could have gentler gravitational tugs, reducing the chaos during mergers. No drama, no debris. This cosmic tidiness forces us to reconsider how galaxies digest their mergers. Is NGC 1277 an exception, or are we missing something fundamental? Next up, another layer of the mystery: the peculiar chemical fingerprints hidden in its stars. Now let's turn our attention to the stars themselves, because even their chemistry tells a strange tale. Inside NGC 1277, astronomers have detected bizarre ratios of elements like magnesium and iron, combinations that don't quite match what we see in other galaxies. It's as if this galaxy's stars were forged under rules we don't yet understand. Usually, stars in old galaxies show predictable patterns. Iron builds up over generations of stellar explosions, while magnesium is more common in early, massive stars. But here, magnesium levels are unusually high compared to iron, suggesting a star formation history that was both rapid and lopsided. Imagine a factory that suddenly churned out nothing but one specific product, then shut down. That's the kind of oddity we're dealing with. One theory points to the galaxy's supermassive black hole. In its youth, it might have triggered intense bursts of star formation, but only for a short time, skewing the chemical mix. Alternatively, the gas clouds that birthed these stars could have been pre-seasoned with extra magnesium, perhaps by ancient supernovas with unusual explosions. Then there's the dark matter angle. Some researchers speculate that NGC 1277's unique gravitational environment, shaped by its invisible dark matter, might have influenced how metals were scattered and absorbed during star formation. It's like baking a cake in zero gravity. The ingredients don't blend the way they should. These chemical quirks aren't just academic curiosities. They're clues hinting that this galaxy either formed under extreme conditions or evolved in ways that defy our textbooks. And speaking of evolution, our next mystery takes us to the aging giants of NGC 1277, an overabundance of red stars that shouldn't be there. Now let's zoom in on the aging stars of NGC 1277. where an unexpected crowd of red giants steals the spotlight. Unlike typical galaxies where these bloated, aging stars appear in modest numbers, NGC 1277 is packed with them almost as if it skipped a few evolutionary steps. Red giants are what stars become when they've burned through most of their hydrogen fuel, puffing up and glowing red as they near the end of their lives. Normally, galaxies have a balanced mix of stars at different life stages, but here the scales tip heavily toward these late-stage giants. It's like walking into a retirement home and finding it overflowing with hardly any younger residents around. So why does this galaxy have such a lopsided population? One possibility is that most of its stars were born in a single, frenzied burst of star formation billions of years ago. Since stars of similar mass age at similar rates, they could now be reaching the red giant phase all at once, like a synchronized cosmic clock. Another theory suggests that the galaxy's unique environment, perhaps influenced by its supermassive black hole or dark matter distribution, altered how stars evolved, speeding some toward old age while stunting others. There's also the chance that NGC 1277 lost its younger stars long ago, stripped away by gravitational tugs from nearby galaxies or swallowed by its own black hole. Without fresh generations of stars to balance the demographics, the red giants dominate the scene. Whatever the reason, this overabundance challenges our models of how galaxies age. Most don't keep such a tight schedule, with stars dying off en masse. Yet here, NGC 1277 seems to march to its own rhythm, another clue that this relic galaxy plays by different rules. And just when you think the surprises end, another oddity appears. Up next, we'll examine the galaxy's oddly massive central bulge, a feature that doesn't quite match its delicate disk. Now let's turn our attention to the puzzling heart of NGC 1277, where its central bulge defies expectations. Most galaxies have a balanced relationship between their bulges and disks, like a well-proportioned body. But here, the bulge is oddly oversized, as if the galaxy skipped arm day at the cosmic gym. A galactic bulge is typically a dense, spherical cluster of stars at the core, while the disk is the flattened, star-filled region spinning around it. In normal galaxies, the bulge's mass correlates with the disk's size and structure. Yet in NGC 1277, the bulge is far heavier than its delicate disk should allow. Imagine a massive boulder perched on a sheet of paper without it tearing. It just doesn't add up. So what could explain this mismatch? One leading theory points to the galaxy's ancient, violent past. If NGC 1277 formed through a series of early, chaotic mergers, those collisions might have funneled stars into the center, puffing up the bulge while leaving the disk relatively untouched. Another idea suggests that the supermassive black hole's gravitational grip could have rearranged nearby stars, packing them tightly into the core. There's also the possibility that the bulge isn't just stars. It might hide unseen mass, like dark matter clumps or even remnants of swallowed dwarf galaxies. Some astronomers speculate that the bulge's extra heft could be throwing off our measurements, making the disk seem lighter by comparison. Whatever the cause, this imbalance forces us to rethink how bulges and disks evolve together. Most galaxies grow in harmony, but NGC 1277's lopsided structure hints at a much stranger history, one where the rules of galactic architecture were bent or broken. And just when we think we've unraveled one mystery, another takes its place. Coming up, we'll explore why this galaxy lacks the star-forming regions we'd expect to find, deepening the enigma of its quiet, aging demeanor. But let's shift gears and peer into another cosmic oddity, NGC 1277's eerie quiet when it comes to star formation. In most galaxies, you'd expect to find bustling nurseries where gas and dust collapse into newborn stars. Yet here, those vibrant regions are conspicuously missing, as if the galaxy hit pause on creation itself. Star-forming regions are typically lit up by young, blue stars and glowing nebulae, but NGC 1277's landscape is starkly different. Its interstellar environment is surprisingly barren, lacking the cold, dense gas clouds needed to spark new stars. Think of it like a factory with all the machinery intact but no raw materials to keep production running. So why is this galaxy so starved of star-forming fuel? One clue lies in its ancient relic status. NGC 1277 may have burned through its gas reserves billions of years ago in a frenzied burst of star formation, leaving little behind. Without fresh gas, perhaps stripped away by interactions with neighboring galaxies or gobbled up by its supermassive black hole, the galaxy simply couldn't replenish its supplies. Another possibility is that the remaining gas is too hot or diffused to collapse. If the black hole's past outbursts or gravitational tides heated the gas, it might resist clumping into star-forming pockets. Alternatively, the galaxy's dark matter halo, if present in an unusual configuration, could be stifling gas accumulation. The absence of star-forming regions isn't just a curiosity, it's a vital clue about how galaxies age. NGC 1277's quietude suggests it's been in retirement for eons, a fossilized snapshot of the early universe's chaos. But as we'll soon see, even a galaxy that stopped making stars can still hold surprises. Next, we'll uncover the faint, mysterious UV emissions hinting at hidden activity beneath its calm exterior. Now, let's unravel another layer of this galactic enigma. Those puzzling ultraviolet emissions flickering from NGC 1277. On the surface, this galaxy appears quiet, even dormant, but these faint UV whispers suggest there's more beneath its serene facade. Ultraviolet light is often the calling card of energetic young stars, the kind you'd expect in star-forming regions. But here's the twist: NGC 1277 isn't supposed to have any. So where is this UV glow coming from? One possibility is that a handful of young stars, perhaps born from tiny, overlooked pockets of gas, are hiding in the galaxy's shadows. These stellar newborns would be rare exceptions in an otherwise ancient stellar population, like finding a single fresh bloom in a field of withered flowers. Another theory points to exotic processes. Maybe the supermassive black hole, despite its quiet demeanor, is still sputtering out faint bursts of energy, heating nearby gas until it emits UV light. There's also a wild card. Stellar remnants like white dwarfs or neutron stars could be interacting with their surroundings, producing UV emissions without the need for youth. Imagine embers left behind by a long-cooled fire, still capable of a faint, eerie glow. Whatever the source, these UV signals challenge our assumption that NGC 1277 is entirely red and dead. This discovery forces astronomers to rethink how relic galaxies evolve. Even in retirement, NGC 1277 might harbor subtle activity, a reminder that the universe rarely follows our neat categorizations. Up next, we'll delve into another unexpected twist: the galaxy's unpredicted magnetic fields, which add yet another layer to its cosmic mystery. But just when we think we've uncovered all of NGC 1277's secrets, it throws another curveball, this time from the invisible forces weaving through its depths. The galaxy's magnetic fields are far stronger than anyone predicted, and they're not playing by the usual rules. Magnetic fields are the universe's silent architects, shaping how gas moves, how stars form, and even how black holes behave. In most galaxies, these fields follow a predictable pattern, aligning with the spiral arms or the disk. But in NGC 1277, they're chaotic, twisting through space with unexpected intensity. Imagine a storm where the winds blow in every direction at once, no rhyme or reason, just raw, untamed energy. One theory suggests these wild magnetic fields are remnants of the galaxy's violent past. If NGC 1277 collided with another galaxy long ago, the turmoil could have scrambled its magnetic lines, leaving them frozen in this frenzied state. Another idea points to the supermassive black hole at its heart. Perhaps its gravitational pull is stretching and amplifying these fields, turning them into cosmic whirlpools. What's truly baffling is how these magnetic forces might be influencing the galaxy's present. They could be trapping gas, preventing it from collapsing into new stars, or even funneling material toward the black hole in ways we don't yet understand. It's a reminder that even in a galaxy that seems quiet, invisible forces are still at work, pulling the strings behind the scenes. And just like that, NGC 1277 proves once again that it's full of surprises. Up next, we'll explore the ghostly traces of ancient mergers' tidal streams that might hold the key to this galaxy's turbulent history. Now, let's turn our attention to something even more elusive: ghostly whispers from NGC 1277's past. Hidden in the darkness around this galaxy, there might be faint, nearly invisible trails of stars and gas, remnants of ancient collisions long forgotten. These ghost tidal streams are like cosmic fingerprints, marking where smaller galaxies were torn apart and absorbed into NGC 1277's vast embrace. Most galaxies show signs of their violent histories: tangled streams of stars, warped disks, or scattered clusters, but here the evidence is missing. That absence is its own mystery. If NGC 1277 devoured other galaxies, where are the scars? Some astronomers think the answer lies in these ghost streams, so faint that our telescopes barely detect them. They could be hiding in plain sight, camouflaged against the blackness of space, their stars dimmed by time. One possibility is that these streams are stretched too thin, their stars spread so far apart they blend into the void. Another theory suggests they've been erased, pulled apart by the galaxy's monstrous gravity, or disrupted by encounters with other cosmic structures. Or perhaps they're simply too old, their stars faded beyond recognition after billions of years. If we could find them, these ghost streams would tell us a story of chaos and rebirth. They might reveal how NGC 1277 grew so massive without leaving behind the usual wreckage. Were the mergers gentle, or did they happen so long ago that time has washed away the evidence? Every missing piece of this puzzle makes the galaxy's past even more mysterious. And as we dig deeper, another question arises: what else is hiding in the shadows of this enigmatic galaxy? Up next, we'll investigate why heavy metals seem clustered in strange pockets, defying the rules of cosmic chemistry. Now, shifting our focus to a puzzling cosmic anomaly, let's examine the strange pockets of heavy metals scattered across NGC 1277. Unlike most galaxies, where metals are evenly dispersed from star formation and supernova explosions, this relic galaxy seems to hoard them in dense, unexpected clusters. It's as if someone dropped cosmic treasure chests in random corners of the galaxy, defying the usual rules of chemistry. One leading theory suggests these metal-rich zones are remnants of ancient hyperactive star formation. Billions of years ago, NGC 1277 might have birthed stars at a frenzied pace, with generations of massive stars exploding in the same regions, leaving behind concentrated layers of heavy elements like iron and magnesium. Over time, these metals didn't mix evenly. Instead, they clumped together, frozen in place when the galaxy's star formation suddenly stopped. Another possibility involves galactic cannibalism. If NGC 1277 devoured smaller, metal-packed galaxies long ago, their debris could have settled unevenly, creating these odd pockets. Yet, there's a hitch: we'd expect to see other signs of such mergers, like tidal streams or distorted shapes. But as we've seen, this galaxy is eerily clean, raising the question: did it digest its meals too neatly, leaving only these metal clusters as crumbs? The mystery deepens when we consider how metals usually behave. Supernova explosions and stellar winds typically scatter elements across vast distances. So why haven't these metals spread out? Some scientists speculate that NGC 1277's unique gravitational field, perhaps shaped by its monstrous black hole or hidden dark matter, could be trapping metals in place like cosmic flypaper. Whatever the cause, these overconcentrated metals challenge our understanding of galactic evolution. They hint at a turbulent past where the rules of chemistry and physics played out differently, or where we're missing a crucial piece of the puzzle. And as we peel back another layer of this enigma, another oddity awaits: the curious absence of cold gas, the lifeblood of star formation. What could have siphoned it away? That's where we're headed next. Now, let's unravel another layer of this galactic mystery: the baffling absence of molecular gas in NGC 1277. In most galaxies, vast clouds of molecular gas act like cosmic nurseries, providing the raw material needed to birth new stars. But here, those clouds are suspiciously missing, leaving astronomers scratching their heads. One likely culprit is the galaxy's supermassive black hole. With a mass of 17 billion suns, this gravitational behemoth could have devoured or ejected the gas, clearing it out like a cosmic vacuum. When black holes feed, they often unleash powerful jets and winds, capable of sweeping gas clean out of a galaxy. But here's the twist: NGC 1277's black hole is strangely quiet. If it didn't expel the gas, where did it go? Another possibility is that the gas was stripped away by external forces. Nestled in the crowded Perseus Cluster, NGC 1277 might have been robbed by its neighbors. As galaxies move through clusters, they can plow through scorching intergalactic gas, which strips away their cooler molecular fuel, a process called ram pressure stripping. Yet, this galaxy shows no obvious scars from such a violent encounter, making the theft all the more puzzling. Or perhaps the gas was used up in a frenzy of star formation long ago. If NGC 1277 burned through its gas supply billions of years earlier than most galaxies, it would explain both the missing gas and the absence of young stars today. But this raises another question: why did the star formation stop so abruptly? Normally, galaxies recycle gas through supernova and stellar winds, creating a self-sustaining cycle. Here, that cycle seems broken, as if someone hit the off switch. The missing molecular gas isn't just an oddity, it's a clue to the galaxy's frozen-in-time state. Without fresh fuel, NGC 1277 can't make new stars, locking it into its relic status. And as we piece together these cosmic breadcrumbs, the next puzzle awaits: the galaxy's paradoxical star formation history, where rapid bursts and sudden halts defy the usual galactic timeline. But let's dig deeper into one of the most baffling quirks of NGC 1277, its star formation history, which defies every expectation. This galaxy didn't just age gracefully. Instead, it burned through its star, making fuel in a cosmic sprint, only to slam on the brakes with no warning. Imagine a factory running at full speed, churning out products non-stop, and then suddenly shutting down overnight, leaving behind only the echoes of its past activity. That's the puzzle astronomers face here. Most galaxies form stars at a steady, predictable pace, balancing gas consumption with replenishment. But NGC 1277 tells a different story. Observations suggest it experienced a violent, hyperactive burst of star formation early in its life, producing stars at a rate far higher than typical galaxies of its size. Then, just as abruptly, everything stopped. No gentle decline, no sputtering fade out, just silence. Why the sudden halt? One theory points to the galaxy's monstrous black hole. Though quiet now, it might have once unleashed enough energy to blast away leftover gas or heat it to temperatures too high for star birth. Another idea is that NGC 1277 simply ran out of fuel too quickly, exhausting its gas supply before recycling mechanisms could kick in. Without fresh material, star formation couldn't continue, leaving the galaxy frozen in time. But here's the real head-scratcher. This rapid rise and sudden stop don't match any known models of galactic evolution. It's like finding a fossilized city where the inhabitants vanished mid-celebration, with no signs of disaster. Did something external intervene, or did the galaxy's own dynamics trigger this abrupt shutdown? The answers could rewrite our understanding of how galaxies live and die. And as we grapple with these questions, another layer of mystery emerges: the peculiar orbits of stars in NGC 1277, hinting at gravitational chaos lurking beneath its serene facade. Now, let's turn our attention to another fascinating quirk of NGC 1277, the strange, almost rebellious paths of its stars. Unlike the orderly, predictable orbits we see in most galaxies, many stars here seem to march to the beat of their own cosmic drum, tracing tilted, chaotic trajectories that defy expectations. Picture a bustling roundabout where every car veers off at sharp, unpredictable angles instead of flowing smoothly. That's the kind of gravitational chaos astronomers are detecting in this galaxy. These stars aren't just misaligned, they're tilted at odd angles, some even looping backward relative to the galaxy's rotation. Such erratic behavior points to a turbulent past, as if something massive yanked the galaxy's stellar population off course long ago. So what could have caused this cosmic disarray? One leading theory suggests a dramatic encounter, perhaps a near-miss collision with another galaxy or a violent merger that never fully settled. Gravitational forces from such an event could have sent stars careening into these peculiar orbits, like billiard balls scattered by a powerful break shot. Another possibility is the lingering influence of the supermassive black hole at the galaxy's heart. Its immense gravity might have slingshotted stars into these bizarre paths, warping the fabric of space around it like a funhouse mirror. But here's the twist: if a merger or close encounter did occur, where's the evidence? NGC 1277 shows no visible scars, no tidal tails, no distorted dust lanes, just these oddly angled stars as silent witnesses. It's a celestial detective story with missing clues, forcing astronomers to reconsider how galaxies interact in dense clusters like Perseus. And as we piece together this puzzle, another layer emerges: the possibility that dark matter, if arranged in clumps or streams, could be tugging on these stars invisibly. Whatever the cause, these anomalous orbits are a stark reminder that even the quietest-looking galaxies can hide violent histories. Up next, we'll explore why the heart of NGC 1277 seems unnervingly calm despite harboring one of the universe's most massive black holes. Now, let's venture into one of the most perplexing contradictions at the core of NGC 1277. With a supermassive black hole weighing 17 billion times our Sun, you'd expect its nucleus to be a raging storm of cosmic activity, yet it's eerily silent. Most galaxies with black holes this colossal shine as quasars or unleashed torrents of X-rays, but here the center is almost meditatively calm, like a sleeping giant. This quiet is anything but ordinary. Typically, a black hole this size should be feasting on surrounding gas, heating it to millions of degrees and lighting up the galaxy with violent outbursts. Instead, NGC 1277's core emits barely a whisper. Astronomers call this state quiescent, but the term hardly explains the mystery. So why isn't this cosmic titan behaving as expected? One clue lies in the galaxy's strange lack of fuel. Remember those missing gas clouds we discussed earlier? Without fresh material to consume, even the hungriest black hole would go dormant. It's like having a roaring fireplace with no logs to burn. But that raises another question: how did such a massive black hole run out of food in the first place? Some theorize that past collisions might have stripped away its gas reserves, while others suggest the black hole itself expelled the fuel in an ancient, unseen outburst, leaving nothing behind to power new activity. Then there's the spin factor. Black holes can enter a kind of hibernation if they rotate too slowly, making it harder for them to attract and swallow matter. Measurements hint that NGC 1277's black hole might be spinning at an unusually sluggish rate, which could explain its silence. But what slowed it down? Was it born that way, or did interactions with other objects break its rotation over eons? The quiet nucleus challenges our assumptions about how black holes and galaxies evolved together. It's as if this relic galaxy hit the pause button on chaos, preserving a snapshot of an entirely different cosmic rulebook. Up next, we'll probe the invisible architects that might be shaping these mysteries, the elusive clumps of dark matter hiding in NGC 1277's shadows. Now, let's turn our attention to the invisible architects that might be pulling the strings in NGC 1277, the elusive clumps of dark matter hiding in its shadows. While we can't see dark matter directly, its gravitational fingerprints are all over this galaxy's strange behavior. Most galaxies are cocooned in vast halos of this mysterious substance, but NGC 1277's dark matter seems to be playing hide and seek. One leading theory suggests that dark matter here isn't spread evenly like a blanket, but instead clumps together in dense, unseen pockets. These hidden knots could be warping space in ways that explain the galaxy's odd gravitational tugs, like stars orbiting too fast or the core's puzzling stillness. Imagine dropping pebbles into a pond. The ripples wouldn't be uniform if the pebbles were clustered unevenly. Dark matter clumps could create similar disruptions in the fabric of the galaxy. But why would dark matter behave differently here? Some researchers propose that NGC 1277's ancient, isolated history left its dark matter uncooked, never smoothed out by collisions or mergers that typically distributed evenly in younger galaxies. Others wonder if this galaxy hosts a rare breed of dark matter, one that clumps more readily than the variety we think fills the cosmos. The implications are staggering. If dark matter here truly gathers in invisible clumps, it could rewrite our understanding of how galaxies form and evolve. Normally, dark matter acts as scaffolding, guiding stars and gas into place. But in NGC 1277, those scaffolds might be tangled or missing entirely, leaving astronomers to piece together a blueprint they've never seen before. Next, we'll examine another piece of this cosmic puzzle: why this galaxy's supermassive black hole seems to ignore the usual rules of energetic feedback, leaving its surroundings eerily untouched. Now, shifting our gaze to another cosmic conundrum, let's unravel why the supermassive black hole at the heart of NGC 1277 remains eerily silent. In most galaxies, a black hole of this staggering mass should be a roaring engine, blasting out fierce winds and radiation that sculpt its surroundings. This process, known as active galactic nucleus feedback, is like a celestial thermostat regulating star formation by heating or expelling gas. Yet here, the black hole seems to have hit the mute button. One clue lies in its diet or lack thereof. For a black hole to produce energetic feedback, it needs a steady stream of material to devour. But NGC 1277's core is strangely starved of gas and dust, leaving its black hole with little to feast on. Imagine a bonfire without wood. No fuel means no flames. Without fresh material falling in, the black hole can't generate the powerful jets or radiation typically seen in active galaxies. Another twist comes from the black hole's own history. Some astronomers suspect it might have already exhausted its fuel reserves billions of years ago, going dormant after a brief but intense period of activity. Think of it like a volcano that erupted catastrophically in the past but now lies quiet, its energy spent. Alternatively, the galaxy's unusual dark matter distribution could be playing a role. Perhaps those invisible clumps we discussed earlier are somehow stifling the flow of gas toward the core. The absence of feedback has real consequences. Without those energetic outbursts, NGC 1277's gas remains cold and undisturbed, which might explain why no new stars are forming. It's as if the galaxy is frozen in time, its evolution paused by the silence of its central giant. This quiet defiance of expectations challenges our models of how black holes and galaxies co-evolve, suggesting some cosmic relationships are far more complex than we imagined. Next, we'll turn to the curious dance of stars in the galaxy's bulge, where their movements defy the usual rules, hinting at forces we've yet to fully understand. Now let's venture deeper into the heart of NGC 1277, where the stars in its central bulge are defying expectations in a cosmic ballet of their own. Normally, the stars in a galaxy's bulge follow predictable orbits, swirling around the core like a well-choreographed dance. But here, the stars move in ways that leave astronomers scratching their heads, some darting at odd angles, others tracing paths that spiral far beyond what standard models predict. One leading theory suggests the galaxy's turbulent past might be to blame. If NGC 1277 experienced a violent merger or close encounter with another galaxy long ago, the gravitational chaos could have sent stars careening into these unusual orbits. Picture a spinning top knocked off balance. It wobbles unpredictably until it settles. Except in this case, the stars never quite settled, leaving behind a kinematic fingerprint of that ancient disruption. Another possibility is the sheer gravitational dominance of the supermassive black hole itself. With a mass of 17 billion suns, its pull could be warping nearby stellar orbits like a tidal force, twisting them into configurations we don't see in typical galaxies. It's as if the black hole is an invisible hand, sculpting the motions of stars in ways that challenge our understanding of galactic dynamics, the most puzzling detail. These odd stellar movements don't align with the bulge's visible mass. Even accounting for the black hole's immense gravity, there's still a mismatch hinting that something unseen, perhaps hidden dark matter or elusive stellar remnants, is nudging these stars off their expected path. This kinematic mystery isn't just a quirk. It's a window into the forces that shape galaxies over eons. By studying these rogue orbits, astronomers hope to unravel how relic galaxies like NGC 1277 evolved differently from their peers. Next, we'll tackle another paradox: why this so-called fossil galaxy might not be as ancient as it seems. But here's the twist: NGC 1277 might not be the cosmic relic we once thought. The label fossil galaxy suggests it's a preserved snapshot of the early universe, untouched by the usual galactic evolution. But what if that's only half the story? Let's peel back the layers of this intriguing debate. On one side, the evidence seems clear. NGC 1277 is packed with ancient stars, lacks young stellar populations, and shows no signs of recent star formation, hallmarks of a galaxy frozen in time. Its chemistry matches what we'd expect from the universe's first massive galaxies, earning it the fossil title. Think of it like a dinosaur bone unearthed after millions of years, perfectly preserved. Yet contradictions lurk beneath the surface. Its stars have unusually high metal content for such an old galaxy, hinting at a burst of rapid star formation long ago, something atypical for early universe relics. Then there's its bizarre black hole, which dwarfs those in similar aged galaxies. Could these quirks mean NGC 1277 isn't a pure fossil, but instead a product of its own chaotic evolution? Some astronomers argue it's both: an ancient galaxy that experienced a brief, violent chapter, altering its trajectory. Perhaps mergers or collisions supercharged its star formation early on, leaving it stranded in a state that mimics but isn't identical to the primordial universe. Others propose it's simply a rare outlier, evolving in isolation under rules we don't yet understand. This debate isn't just academic. If NGC 1277 isn't a true fossil, it challenges how we define relic galaxies and forces us to rethink their role in cosmic history. Up next, another puzzle: the ghostly absence of interstellar gas in this enigmatic galaxy. But let's shift gears for a moment and focus on something even more puzzling: the near-total absence of interstellar gas in NGC 1277. Interstellar gas is the lifeblood of galaxies, the raw material that fuels star formation and keeps a galaxy vibrant. Without it, galaxies like ours would have run out of new stars billions of years ago. Yet NGC 1277 seems to have somehow lost almost all of it. So where did it go? One leading theory suggests the galaxy's monstrous black hole might be to blame. As gas falls toward the black hole, it heats up and gets blasted away in powerful jets, effectively sterilizing the galaxy. Another possibility is that NGC 1277 was stripped clean by its environment. Nestled in the crowded Perseus Cluster, it could have had its gas ripped away by gravitational tugs from neighboring galaxies or the hot plasma filling the cluster. Imagine a tree in a windstorm losing its leaves one by one until nothing remains. But here's the real kicker. This isn't just about missing gas. The absence of interstellar material has trapped NGC 1277 in a kind of cosmic retirement. Without fresh gas to form new stars, the galaxy is stuck with an aging population, quietly fading over time. It's a stark contrast to younger galaxies, where star formation keeps things dynamic and bright. What makes this even stranger is that most relic galaxies still hold onto traces of gas, enough to spark the occasional new star. NGC 1277, however, seems to have crossed a point of no return. Whether it's due to its black hole, its hostile neighborhood, or some other unseen force, the result is the same: a galaxy frozen in time, not just by its ancient stars but by the eerie emptiness between them. Up next, another clue to this galaxy's mystery: its surprisingly dense stellar halo, a ghostly shell of stars that shouldn't be there. Now let's turn our attention to something that defies expectations: the surprisingly dense stellar halo enveloping NGC 1277. Most galaxies, including our own Milky Way, have halos made up of sparse, ancient stars scattered thinly around their outer edges. But NGC 1277 doesn't play by those rules. Its halo is packed with stars far denser than astronomers would predict for a galaxy of its size and age. So what's going on here? One possibility is that this galaxy has a violent past. When galaxies collide, their stars can be flung outward, forming a thicker halo over time. If NGC 1277 experienced multiple mergers in its early history, that could explain why its halo is so crowded. Another theory points to its environment being in the dense Perseus Cluster might have allowed it to steal stars from neighboring galaxies, puffing up its halo like a cosmic thief. But here's where it gets even more intriguing. The stars in this halo aren't just numerous, they're also unusually metal-rich. That's odd because halo stars are typically old and metal-poor, relics from the early universe. This suggests NGC 1277's halo wasn't built through gentle accretion, but through something more dramatic, like a series of clashes with smaller, metal-rich galaxies. The mystery deepens when we consider how this fits with the galaxy's other oddities. A dense halo, combined with its missing gas and overmassive black hole, paints a picture of a galaxy that's been through the cosmic ringer. It's as if every piece of NGC 1277's story is shouting, "This isn't normal." Up next, another twist. The black hole at this galaxy's heart isn't just massive, it spins in a way that's got scientists scratching their heads. Now let's peer into the heart of NGC 1277, where its supermassive black hole isn't just breaking the rules with its size, it's also doing something unexpected with its spin. Most black holes rotate at speeds that align with predictions, but this one, it's spinning at a rate that leaves astronomers baffled. Measurements suggest this black hole isn't just fast or slow, it's spinning in a way that doesn't match typical models. Normally, a black hole's spin is shaped by how it feeds, gobble up matter in a steady stream, and it spins faster, collide with another black hole, and the merger can send it into a wild, unpredictable rotation. But here's the puzzle. NGC 1277's black hole is both monstrous and spinning unusually, despite showing little signs of recent feeding or mergers. One theory points to its ancient past. Maybe this black hole formed in the early universe under conditions so extreme that it was born with a bizarre spin. Another idea, it could have devoured smaller black holes in a very specific way, nudging its rotation into this odd state without leaving the usual traces. What makes this even stranger is how the spin might connect to the galaxy's other mysteries. A rapidly spinning black hole can warp space-time around it, potentially influencing star orbits or even hiding dark matter in ways we don't yet understand. It's yet another piece of the puzzle that makes NGC 1277 so uniquely perplexing. And speaking of puzzles, up next we'll tackle the curious case of the galaxy's redshift anomaly, where even its motion through space seems to defy expectations. Now let's unravel another layer of NGC 1277's mystery, the peculiar redshift anomaly that has astronomers scratching their heads. Redshift, the stretching of light as an object moves away from us, is a cornerstone of measuring cosmic distances and motions. But this galaxy's redshift readings don't quite add up. Normally, redshift is a straightforward clue. Higher values mean faster movement away from us, while lower ones suggest the opposite. Yet NGC 1277's measurements flicker slightly, as if something unseen is tugging at it. These inconsistencies are small but significant, hinting at forces we can't yet detect. One possibility, hidden structures like dark matter clumps or even an undetected companion galaxy, might be warping the galaxy's motion subtly. Another theory suggests the supermassive black hole's bizarre spin could be distorting space-time nearby, skewing our observations. Or perhaps the galaxy is caught in a delicate dance with nearby NGC 1275, its neighbor creating gravitational ripples we're only now noticing. What makes this anomaly so intriguing is its connection to the bigger picture. If redshift, a tool we rely on to map the universe, can be thrown off by unseen factors, what else might we be missing? It's a humbling reminder that even our best methods have blind spots, and NGC 1277 is expertly exposing them. Up next, we'll delve into another head-scratcher: why this galaxy's colossal black hole isn't lighting up the skies as an active galactic nucleus despite its staggering mass. The plot thickens, shifting our focus to another puzzling aspect of NGC 1277. Let's tackle the curious absence of an obscured active galactic nucleus, or AN. Given the galaxy's supermassive black hole weighing in at a staggering 17 billion times the mass of our Sun, you'd expect it to be a powerhouse of activity, shrouded in gas and dust as it devours surrounding material. Yet, surprisingly, there's no sign of the telltale glow from an obscured AGN. Active galactic nuclei typically light up when black holes feed, heating up nearby gas and dust until it emits intense radiation across the spectrum. In many galaxies, this process is hidden behind thick clouds of material, creating what we call an obscured AGN. But NGC 1277's black hole seems unusually quiet, almost as if it's on a cosmic diet. So why the silence? One possibility is that the black hole has simply run out of fuel. The galaxy's severe lack of gas, especially the cold, dense gas needed to feed such a beast, could explain why it's not active. Another theory suggests the black hole might have already consumed most of its surrounding material in a frenzied feast long ago, leaving it dormant now. But here's the twist: even dormant black holes occasionally flicker to life when stray gas or stars wander too close. The fact that we've seen no such flickers in NGC 1277 hints at something even stranger. Maybe the black hole's environment is unusually clean, with no loose material to fall in. Or perhaps its magnetic fields are so strong they're preventing gas from reaching the event horizon altogether. This quietness challenges our expectations. Supermassive black holes this hefty are usually showstoppers, blasting out energy that shapes their entire galaxy. NGC 1277's black hole, though, is a recluse, and that makes it a fascinating outlier. Coming up, we'll examine another anomaly, the galaxy's puzzling stellar mass-to-light ratio, which refuses to match predictions. The mysteries only deepen. Now, let's unravel another head-scratcher in NGC 1277, its baffling stellar mass-to-light ratio. Normally, astronomers can predict how much light a galaxy should emit based on its mass. It's like estimating how bright a light bulb should be if you know its wattage. But NGC 1277 defies this logic. Its mass-to-light ratio is way off, meaning it's either much heavier or much dimmer than it should be. So what's throwing the numbers out of whack? One clue lies in the galaxy's ancient stellar population. Packed with old, red stars that burn faintly compared to younger, brighter stars, NGC 1277 might simply be emitting less light than expected for its mass. Think of it as a room full of dim candles instead of a few bright floodlights, same total wax, less glow. But there's more to it. The galaxy's dark matter content, or apparent lack thereof, could also be muddying the math. If dark matter isn't distributed as predicted, the visible stars might bear more of the mass burden, skewing the ratio. Alternatively, unusual stellar compositions, like an overabundance of dense neutron stars or white dwarfs, could add unseen heft without contributing much light. The real puzzle, even when accounting for these factors, the numbers still don't quite add up. Some researchers suggest we might be missing a piece of the puzzle entirely, perhaps an unknown form of dark matter or a quirks in how stars formed here. This mismatch isn't just a bookkeeping error. It challenges our understanding of how galaxies assemble and evolve. If we can't reliably measure a galaxy's mass from its light, what does that mean for our cosmic models? NGC 1277 keeps us guessing, and that's what makes it so thrilling. Next, we'll turn our attention to another oddity, the strangely arranged planetary nebulae scattered across the galaxy, defying expectations yet again. Let's zoom in on another cosmic quirk in NGC 1277, the bizarre way its planetary nebulae are scattered across the galaxy. These glowing shells of gas ejected by dying stars usually follow predictable patterns like sprinkles on a cupcake. But here, they're arranged in a way that's got astronomers scratching their heads. Instead of being evenly distributed or clustered near the galactic center, these nebulae appear in unexpected pockets, some oddly clumped together, others strangely sparse. It's as if someone tossed them across the galaxy without any rhyme or reason. One theory suggests this chaos might trace back to NGC 1277's violent past. Mergers or close encounters with other galaxies could have yanked stars and their planetary nebulae into these irregular orbits, but there's another twist: the nebulae's chemistry. Some show unusual abundances of heavy elements, hinting that the stars that created them might have formed under unique conditions. Could this tie into the galaxy's rapid early star formation spree? Or does it point to hidden forces like unseen dark matter clumps tugging everything out of place? Either way, this jumbled map of planetary nebulae adds another layer to the mystery. It's a reminder that even the quietest-looking galaxies can hide turbulent histories, and NGC 1277 seems determined to keep its secrets a little longer. Up next, we'll dig into another surprise, the globular clusters that somehow seem older than the galaxy itself. Now, here's something that truly bends the rules of cosmic timekeeping: the globular clusters in NGC 1277 that somehow seem older than the galaxy itself. These dense spherical groups of stars are typically ancient, but in this case, their age doesn't just hint at old age, it outright contradicts what we'd expect. Globular clusters are like galactic fossils, often forming alongside their host galaxies in the early universe. But in NGC 1277, these clusters appear even more ancient than the galaxy's estimated age. It's as if they're relics from a time before the galaxy even existed. How is that possible? One idea is that these clusters were stolen. If NGC 1277 cannibalized smaller galaxies in its past, it could have absorbed their older globular clusters, grafting them onto its own history. Another twist: the cluster's chemical makeup. Their stars show fewer heavy elements than the galaxy's main population, suggesting they formed in a different environment, one less enriched by generations of star explosions. This mismatch adds weight to the theft theory, but there's a wilder possibility. Could these clusters be leftovers from a completely different era of the universe, one we don't fully understand yet? Either way, these two old globular clusters are another piece of the puzzle that refuses to fit neatly. They challenge not just our understanding of NGC 1277, but the very timeline of how galaxies and their stellar companions grow up together. And speaking of things that don't add up, wait until you hear about the galaxy's puzzling absence of cold gas, the fuel that should be sparking new stars but somehow went missing. But here's where the mystery deepens. NGC 1277 isn't just missing a few cosmic ingredients, it's missing something fundamental: cold gas. Think of cold gas as the galactic grocery store, the essential fuel for cooking up new stars. Without it, star formation grinds to a halt, and yet this galaxy, despite its age and massive black hole, has almost none of it. Most galaxies, even old ones, hold onto at least some reservoirs of cold gas, drifting in their outer reaches or tucked away in dense clouds, but NGC 1277's shelves are bare. One theory suggests its supermassive black hole might be to blame. When black holes feed, they can blast out energy, heating up or even blowing away nearby gas. But here's the catch: NGC 1277's black hole is oddly quiet. If it isn't actively devouring gas, why is there none left? Another possibility. The galaxy might have been stripped clean by its environment. Nestled in the crowded Perseus Cluster, it could have had its gas torn away by gravitational tugs from neighboring galaxies or scorched off by the cluster's superheated plasma. But that doesn't fully explain why other galaxies in similar environments still cling to their gas. Then there's the strangest idea of all: what if the gas was never there to begin with? Some models suggest relic galaxies like this one might have formed in an era when the universe was too hot for cold gas to accumulate efficiently. That would mean NGC 1277's missing gas isn't a mystery, it's a cosmic relic frozen in time. Whatever the reason, this absence isn't just a curiosity. It's a glaring clue that our understanding of how galaxies live and die might be missing something too. And with that in mind, let's turn to another oddity. How does a galaxy this old manage to keep its disk so eerily thin? Now, shifting our gaze to another cosmic puzzle, let's unravel the mystery of NGC 1277's thin disk. Picture a galaxy's disk like a spinning vinyl record over time. Cosmic turbulence, collisions, and mergers tend to warp or thicken it, leaving older galaxies looking more like a warped frisbee than a pristine disk. Yet here's the paradox: this ancient galaxy's disk remains razor-thin, defying expectations. Most older galaxies show signs of wear and tear, their disks puffed up by gravitational disturbances or heated by stellar encounters. But NGC 1277's disk is eerily undisturbed, as if time forgot to leave its mark. One explanation: this relic galaxy might have lived a sheltered life, avoiding the chaotic mergers that typically bulk up a disk. Without recent collisions to stir things up, its stars could have settled into an unusually orderly, flat arrangement. But that raises another question: how did it dodge cosmic chaos for so long? In a crowded cluster like Perseus, mergers are practically inevitable. Some theorists suggest the galaxy's immense dark matter halo, if it exists, might have acted like a protective shield, fending off disruptive encounters. Others propose its stars formed so quickly and efficiently early on that they locked into stable orbits, resisting later disturbances. Then there's the wild card: what if the disk isn't as fragile as we think? New simulations hint that certain gravitational conditions could let a disk stay thin for billions of years, even in a turbulent universe. If true, NGC 1277 isn't an anomaly. It's a rare glimpse of how galaxies might evolve under perfect cosmic conditions. Whatever the answer, this delicate disk challenges our assumptions about galactic aging. It's as if the galaxy found a way to hit pause on time, preserving its youthful structure in a universe that rarely lets anything stay untouched. And that brings us to yet another enigma. Why does this ancient galaxy seem to harbor an overabundance of binary stars? Turning our attention to another cosmic oddity, let's explore the curious case of NGC 1277's binary stars. Most galaxies have a sprinkling of these paired stellar systems, but this Relic galaxy seems to have an entire treasure trove of them. Binary stars, two stars locked in a gravitational dance around a shared center, are common, but not in the staggering numbers observed here. What makes this overabundance so puzzling? For starters, binary stars typically form in dense, gas-rich environments where gravity can easily bind pairs together. Yet NGC 1277 lacks the gas and young stars usually associated with such prolific binary formation. So where did all these paired stars come from? One theory points to the galaxy's ancient, rapid star-forming phase. If stars were born in tight clusters during its youth, close encounters could have forced many into binary partnerships. Another possibility is that the galaxy's unique environment somehow preserved these binaries over billions of years. In most galaxies, gravitational interactions with neighboring stars or black holes would disrupt these delicate pairings. But NGC 1277's quiet, collision-free history might have let them endure. There's even a chance that some of these binaries are imposter stars that appear paired due to our line of sight but aren't actually bound. The implications are fascinating. If these binaries are real and abundant, they could skew our measurements of the galaxy's mass or influence its dynamics in unexpected ways. Some researchers speculate that binary stars might contribute to the galaxy's thin disk stability, their mutual orbits acting like tiny anchors against disturbances. Yet the mystery deepens when we consider how little we still know about binary stars in such ancient galaxies. Are they a cosmic relic, a clue to the chaotic conditions of the early universe? Or is NGC 1277 quietly rewriting the rules of stellar partnerships? Whatever the answer, this overabundance adds yet another layer to the galaxy's enigma and leads us to the next puzzle, the controversial idea that NGC 1277 might be a dark galaxy dominated by exotic forms of unseen matter. Now let's venture into one of the most provocative theories about NGC 1277, the idea that it might be a dark galaxy. This hypothesis suggests that the galaxy's strangest behaviors could be explained not by the ordinary matter we see, stars, gas, dust, but by something far more mysterious. Dark matter, the invisible stuff that makes up most of the universe's mass, usually hides in the shadows, revealing itself only through gravity. But in NGC 1277, some scientists argue dark matter might not just lurk in the background, it could be the star of the show. The galaxy's bizarre gravitational effects, missing satellite galaxies, and oddly high-speed stellar orbits all hint at an unseen hand at work. What if the dark matter here isn't like the ordinary cold dark matter we expect? Some theories propose it could be warm, dark matter particles lighter and faster than the standard model predicts. Others speculate about self-interacting dark matter, particles that bump into each other, creating strange density patterns. These exotic forms could explain why NGC 1277 looks so different from typical galaxies. Even more intriguing is the idea that this galaxy might be a cosmic fossil from a time when dark matter behaved differently. If conditions in the early universe allowed unusual dark matter structures to form, NGC 1277 could be one of the rare survivors. Its relics of ancient stars and undisturbed orbits might be clues to a long-lost era of dark matter dominance. Of course, not everyone is convinced. Critics point out that dark matter alone can't explain every puzzle, like the galaxy's overabundance of binary stars or its oddly quiet black hole. But whether this hypothesis holds up or not, the very possibility forces us to rethink how galaxies form and evolve. Maybe NGC 1277 isn't just an oddball, it's a glimpse into the dark side of cosmic history. And that brings us to the final question: what's next for this enigmatic galaxy? As we peer into its future, new mysteries are waiting to unfold. Now, turning our gaze to what lies ahead, let's ponder the ultimate fate of NGC 1277. This galaxy, with its peculiar mix of ancient stars, a monstrous black hole, and dark matter mysteries, stands at a cosmic crossroads. Will it remain a relic of the past, or is its story far from over? One possibility is that NGC 1277 continues its quiet existence, frozen in time. Without fresh gas to fuel star formation, its stellar population will slowly fade, leaving behind a dim, aging galaxy. Its supermassive black hole, already unusually quiet, might remain dormant, a sleeping giant in the void. But even in this seemingly stagnant future, gravitational interactions with neighboring galaxies could stir things up. The Perseus Cluster, where NGC 1277 resides, is a bustling cosmic neighborhood. A close encounter with another galaxy, perhaps even the active NGC 1275, could disrupt its delicate balance, triggering unpredictable changes. Another scenario suggests a more dramatic end. Over billions of years, the relentless pull of the cluster's gravity might tear NGC 1277 apart. Its stars could be scattered into the intergalactic medium, while its black hole merges with another, unleashing gravitational waves. Alternatively, if exotic dark matter truly dominates the galaxy, its unusual properties might shield it from such destruction, allowing it to endure long after other galaxies have faded. Then there's the wild card: our own understanding. As telescopes grow more powerful and theories evolve, we might uncover new clues that rewrite NGC 1277's future. Perhaps it holds secrets about dark matter or galaxy formation that we haven't even imagined yet. Whatever the answer, this cosmic oddball reminds us that the universe is full of surprises. And with that, we wrap up our journey through the 50 strangest phenomena of NGC 1277, a galaxy that challenges everything we thought we knew about the cosmos. If you've enjoyed unraveling these mysteries with us, don't forget to like, subscribe, and hit the notification bell for more deep dives into the universe's most baffling wonders. Let us know in the comments, what do you think lies ahead for NGC 1277? As we bring our cosmic journey to a close, let's take a moment to reflect on the 50 strangest phenomena that make NGC 1277 such a galactic enigma. From its missing dark matter halo to its overmassive black hole, from its strangely ancient stars to its puzzling radio silence, this galaxy defies nearly every expectation we have about how galaxies should behave. Each mystery we've explored, whether it's the lack of young stars, the unexplained X-ray bursts, or the curious absence of satellite galaxies, chips away at our current understanding of cosmic evolution. NGC 1277 isn't just an outlier, it's a challenge, pushing astronomers to rethink the rules of galaxy formation and dark matter's role in shaping the universe. What makes this relic galaxy even more fascinating is the possibility that it's not alone. Could there be other NGC 1277s lurking in the cosmos, hiding secrets about the early universe? If so, what might they teach us about the forces that shaped everything we see today? The answers could rewrite textbooks or reveal entirely new chapters in our quest to understand the cosmos. Before we part ways, we'd love to hear your thoughts. Which of these 50 phenomena surprised you the most? Do you think relic galaxies like this one hold the key to unlocking dark matter's deepest secrets? Drop your theories and questions in the comments below. We're just as curious as you are. And if you've enjoyed this deep dive into the universe's oddballs, don't forget to like, subscribe, and hit that notification bell so you never miss our next adventure into the unknown. Until then, keep looking up because the universe always has one more mystery waiting to be uncovered.